Now we're going to talk about speed and velocity. The Large Hadron Collider takes protons and smashes them together at close to the speed of light, and it creates particles. And these interactions we can see like in this depiction here, where the particles smash together and then new particles are created, and those new particles are detected in the detector and measured. And so as they spread out, they cover a certain distance over a period of time, and depending on their mass, depending on their energy, they could go to different levels within the detectors. And so looking at speed and velocity is very important in research as well as in other areas. This is a graph depicting some of the data coming from a Large Hadron Collider. And so after collecting lots and lots of data, they can come to conclusions and determine if there are new particles created. So the way we define speed is we look at the distance covered in a period of time. And we look at distance, and we'll be using the SI units for distance, which is the meter. And for time, we'll be using the second. And so the units that we have will be here in meters per second. And this will tell us, and this is for average. The average speed is looking at the distance over a period of time. And speed is always a positive number because there's no direction with speed. And so just think about your speedometer in your car. It doesn't know where you're going, the direction you're going, but just tells you how fast you're going, and that's speed. Now velocity is looking at displacement over a period of time, and this can be depicted as delta S or delta X over time. And so we look at the displacement in meters, and we look at the time again in seconds. And the key here is we're looking at the change in displacement now. And it's important in this to understand the difference between speed and velocity. So velocity can be positive or negative depending on the direction, and we must have direction with velocity, and we'll look at some examples of how this works. So when we look at speed and velocity, if we wanted a situation where average speed and average velocity are zero, that's pretty easy. That would be like somebody standing in one place and not moving. The speed distance over time is zero, the velocity displacement over time is zero. Now if we wanted average speed and average velocity to be non-zero, then we could either be walking this way or walking this way, and our distance over time and our displacement over time would not be zero. It would have some value. And then average speed, non-zero, velocity zero. This is where it's a little bit tougher to think through. So let's say we had a situation like this. We went over here and then we came back to our original location. So if we did that, our displacement would be zero. So our velocity, delta x over t, would be zero because the displacement is zero. However, how many seconds? Let's say it was like 10 seconds. But then our distance, we would count our distance divided by our time. So our speed would have some value in meters per second. So again, being distance over time, we would have some speed. So let's take a look at this situation where we're located at the origin and we move from the origin to positive 10 and then back with an average speed of 0.5. So you can illustrate that. 0 meters, 10 meters. And so we go here and go back, and this is our speed. So it's a good idea when we're working these out to actually put our variables with our values, so we can do that. And we have our distance, which is 10 out and then 10 back, so distance is 20 meters. So we want to find out how we can do that, and that's really, how much time we want to do there. So speed equals distance over time. We have 0.5 equals our distance, which is 20 over time. Now we're going to have to cross multiply. So time times 0.5 equals 20. Divide both sides by 0.5. So the time that it's going to take would be 40 seconds. Now if we look at velocity, you'll probably know already what's going on with that because we just kind of looked at that. The displacement, what's the displacement? It's 0. We started at 0, we finished at 0. So our velocity is 0. While the time that it would take to have a speed of 0.5 would be 40 seconds. Okay, so for this one, I want you to try to work this one out. A car makes a trip of 1.5 laps around a circular track. The diameter is 50 meters, or 100 meters rather. So let's go ahead and illustrate that. Let's assume the car starts down here. Diameter is 100, so the radius would be 50 meters. And we want to find the average speed. And then the second part, we want to find the average velocity. I gave a hint up here, and we have a half a minute, so we're going to have to be careful there with our units. So 0.5 minutes, we're going to need to get that into seconds. And you can do that. So go ahead and try that, and then enter your answer, and we'll go from there. Okay, so the circumference is 314.16 meters, and if we go around 1.5 times, it's going to be 1.5 times that. So 1.5 times the circumference would be our total distance, which is 471.24, and we have our time, which is 30 seconds. So our average speed is 15.7. So if we look at average velocity now, we have to think about where we started, where we finished. So we started here, and we finished, if we go all the way around once, and then up to here. So our displacement would be 100 meters north, and so if we calculate that, we would have our displacement as 100 meters north over 30 seconds. So this would be our velocity, and so that was a little bit more challenging to think through there, but hopefully now you feel good about that. In this one, we're looking at how long it will take the sound of a starting gun to reach the ears of the sprinters if the starter is stationed at the finish line. So this is kind of a different situation. Usually the starter will start actually at the starting line, and so based on the speed of sound here, we can see how much of a factor this would make. So you can draw out the person. We have the 100-meter mark, and we have the gun down here. And so we want to find out how long, how much time will it take. So again, speed is distance over time, right? And our speed now is 340 meters per second. Our distance is 100 meters, so we're solving for time. So we got to be careful here, cross multiply. 340 times time equals 100 meters. We solve for time, divide both sides by 340. And we'll get our time as 0.294 seconds. And so that could definitely make a difference in a race, if a 100-meter race, and it takes that long for the sound to reach there.